So I actually find the results section to typically be the easiest part to complete of a research paper because the writing is sort of already done. All of the complicated construction of the paper goes into figuring out what variables to include, how to build the models, making sure that the code works. But once you have all of that in place, you just have a regression and analysis, your output, and you just have to describe it. And there's not a lot of sort of art that goes into that. It's a lot, it's just presenting the information, right? What did you find? You told me in the methodology section what you were going to do. Now you've done it. What did you find? And so the results section is going to be built around your regression. So I'll come here and I'll write my regression. So summary, LM, my dependent variable is nat spec, and I'm testing the effect of party ID, age, and degree. My data is called DAT. So I run that. I've got my regression output. I want to copy this into my Word document so that the reader can see exactly what I found, right? You'll describe it. I'll describe it for the reader, but I also want to make sure that if they want to see anything else going on with it, that they can see exactly what I found. And so I'll create a section called results. And what I need to do is go and interpret each variable. Tell the reader exactly what I found in this. So, like I've said before, I like to constantly remind the reader what my paper is doing. And so I'll start my results section by actually just reiterating what my analysis was. I know I just wrote this in my methodology, it's in my introduction, right? I'll talk about it in the conclusion, but there's it's a repetition that sort of breeds clarity. So this paper tested the effect of party identification, age, and education on whether individuals agreed the United States spends too little on space exploration. Okay, just to orient, right, what are the results, analyzing what is this paper talking about, and then I'll go through and talk about each independent variable individually. With only 3 independent variables, you want to talk about each one, whether it's significant or not. And this is just basically using the guidelines for regression interpretation that there is in the textbook if you want to. You can be sort of a little bit more detailed or shift some different things in the way you describe it. You can be as sort of as direct as you want. And so I'll just start at the top of the regression output here, being an independent. As compared to a Democrat, Democrat is the omitted category here, right? I've got a coefficient for independent and Republican. These are being compared to Democrats. So being an independent compared to a Democrat is associated with an individual being 0.017 less likely to say the US spends too little on space. That result is not significant. Being a Republican, and I'm not going to say compared to a Democrat again. I want to avoid being sort of overly repetitious in sort of the interpretations, but you can do whatever you feel comfortable with. Being a Republican is associated with individuals being 0.08 more likely to agree the US spends too little on space, and that difference is slightly significant. Right, we have the p-value is about 0.06, so it's sort of almost significant. We have a dot here. So it's not a very strong finding, but there is sort of some association there. And that's surprising, right? I predicted that Democrats would be more likely to agree with the statement. This is showing that Republicans are actually the most likely partisan group to say that we spend too little on space. And so what I might add here is contrary to my predictions, right? Which is okay. It's okay that that was wrong, right? We learned something new. And so that's something that I'll probably swing back to in the conclusion to try and discuss why I had predicted that Democrats would support more spending on space, more spending on government in general. But here I find that Republicans are actually more likely to think that. Moving on to age, a 1 unit change in age is associated with a 0.001 decrease in likelihood to say we spend too little on space exploration, and that is not significant. Finally, higher levels of education are associated with, so education has 5 levels, and so I should do it as, so a 1 unit change. A 1 unit change in education is associated with a 0.03 increase in the likelihood of saying we spend too little on space, and that change is significant. And so that's it. That's it for the results section, right? I'm just going over what I have found. And so all the discussion of what this means and what we learned from this, that goes into the conclusion. But here we're just reviewing the results of the statistical test.